that you can apply without going through the first principle. But remember, that is the easiest way. But if the question is given to you, obtain from the first principle, then you have to use the first principle formula. So let's see the techniques of differentiation. Then later we go to the roots of what? Differentiation. So let's go through. So we start with the first technique. So these are the techniques. So these are the techniques. Alright, so the first technique is slope of a constant. Slope of a constant. So we have, let's say y is equal to 5, y is equal to 2, y is equal to, in general, c. How do we do the derivative of it? So if we have, let's say, the s or the Cartesian plane, we have the s axis here, we have the y axis, and we have our constant here to be c. So you see, we can have a straight line here, and this straight line is y is equal to c. Now, from equation of a straight line, we can have y is equal to mx plus c. That is equation of a straight line. So you having here to be y is equal to c means that the end here, which is the slope, and we know the slope is the same as what y ds is equal to what? 0. Because if the end there is 0, you are going to have y is equal to what? C. So that means that we are going to get y to be equal to c. So in general, anytime you are to take the derivative of any constant, which is c, is equal to 0. And it's what explained from the general formula of a straight line. Alright, so let's try with some example. Let's say the derivative of 5. What do we say? 0. The derivative of 6. 0. Even if the whole world is a constant, the derivative of the whole world will be what? 0. That's the beauty of mathematics. So somebody will say, what about the negative numbers? It doesn't matter. Negative 1,000, negative 2,000 is still a constant, so they are all 0. I hope it's clear. Alright, so let's see how we can let's see another technique, that is how to take derivative of a polynomial function. Then after that we come to sum and difference of polynomial functions. Then we go our way. Alright, so we are still on the technique. Alright, so let's continue. So the second technique, that is derivative of a polynomial. Derivative of a polynomial function. We all know that a polynomial function is always in the form y is equal to a to the power n. You can get it. It can continuous. It can be let's say 2x squared plus x is a polynomial function. 2x power 1000 plus something is still a polynomial function. But in this case, we are considering only it from this form. So anytime you have something like this, it means that you are having a polynomial function. So we have to define something so that we continue to see how we take derivative of it. So what will you call this A? Because the A here is the coefficient. The N here is the what? Is the exponent. Or what will you say? Power. Power. So how do we take derivative of this polynomial function? Simple in this way. Watch me more. We have the coefficient and we have the power. So you just say that multiply the power by the coefficient and subtract 1 from the power. Simple. So you multiply the power by the coefficient. Repeat the x value and subtract 1 from the power. And that gives the general form of how we take derivative of any polynomial function. Yeah, any polynomial function. You can take derivative of it. Do you know? Okay, I will tell you later. Let's continue. So, in general, this is what we have. So you can write it in words so that it will help you to memorize it fast. Multiply the power by the coefficient and subtract 1 from the power. Simple. In this way, you can find any derivative of any polynomial function. Any polynomial function you have in this world, if only it's in the form of y is equal to a to the power n, then we can treat it as this. So let's see some examples so that we see what to do for the next. Alright. So we can have an example like, we can have an example 1. Me, I don't like numbering it, but you can number it. Example 1. Let's say y is equal to 5h to the power 4. Now the 5 is 7 as the a here, and the 4 is 7 as the n here. The s is always there. So what will you do? Will you memorize this? No. Never. Multiply the power by the coefficient. So we have the power, we have the coefficient. So the dy or the derivative of 5h to the power 4 dx will be 5 being multiplied by the power, beat the s, and subtract 1 from the power. And that is going to give you 20s to the power 3. With this, if the question is there, without doing this, just by looking at it, you can get the answer. So, let's see. Y is equal to x to the power -5. What is the coefficient? 1. What is the power? -5. So dy dx is 1 times -5 x -5. So try 1 from it. How are we going to see that? Alright. So here will be -5x to the power -6. And you have your answer. Nice. Alright. So you can explore, okay? You can try as much as you can. Let's say y is equal to 6x to the power 3. or y is equal to 7x power negative 2. You can solve it on your own. You see, without even using pen or whatever, you can just look at this one. 6 times 3 gives you 6 to 18, right? So if 6 to 3 is 18, subtract 1 from this. So this one will be 18x to the power what? 2. Just like that, you go your way. Alright, so you solve this on your own. So now let's see how we can take derivative of a function in terms of what? Square roots and cubic roots and others. And you will love it. Alright. Now, there is something that you don't have to forget in your indices, that you have something in this form is the same as a m over what? N. We are going to use this idea to assist us in finding the derivative of what? The function. Okay. Alright, so don't forget this. And you know that anytime you have a square root without anything here, it's the same as 2. So this one 2 is the same as 1. So this one will be a 1 over 2. How we can see that? Alright. So let's see this question. Cubic root of a square. Before you can take the derivative of this, you know that it has to be in the form as to the power what? N. But with this one, it's not in the form of as to the power what? N. You can say your power is 2 and your coefficient is 1. Will you say 3 or the roots? Actually, alright, so we leave this one go in the form x, then 2 over the 3. How you can see it? Alright. So with this, you can see that this is the power and the coefficient is the what? Is the 1. So the derivative will give us 2 over 3. That's multiplying this by the 1 x. Then 2 over 3, subtract 1 from it. Then you get your answer. Actually, I always tell you that I don't believe myself, so I take my calculator. 2 over 3 minus 1. That will be negative 1 over 3. So 2 over 3x negative 1 over 3. So that will be the results for that. We have to explore in solving more questions, okay? As a student or as a mathematics student, your only weapon is solving more of what? Questions. We can also get y is equal to 2 over 3, something like this. First of all, you know this can be written as that, right? You have to also bear in mind that this is not in the proper form. It's not in the form like y is equal to as or to the power what? N. So we have to rewrite this one well. So this one you can write it 2 times 1 over s to the power what? Half. Which is 2s negative 1 over 2. Or we can write this as this. From your indices. Don't forget that. Is that not so? Alright. So from here, we can now take our derivative. Why? Tell me. The coefficient is there and the power is there. So the dy dx is going to be 2 times the negative half x So this will cancel this, being equal to, I hope you can see from there. I trust you. So this cancel this, we are left with negative s. Then, hey, calculator now. I don't trust myself. So we have negative half minus 1. I hope you are also using your calculator. Use it too. And you get negative 3 over 2. So here will be negative 3 over 2. And that will be your final answer for it. You see, it's very simple. The only thing that you have to bear in mind that if it's not in the form, and what is that form? That is y is equal to a raised to the power what? S to the power n. If it's not in that form, you can't take the derivative of it. Just simple as that. Alright. Moving to the another technique of the derivative, that is derivative of sum and difference. Derivative of sum and difference of polynomial functions. So that means that it's like you having a function, let's say f of s, or you can see that plus or minus. That's why we say sum and what? Difference. Sum and what? Difference. Alright. So plus or minus the g of what? S. So whenever you have two polynomial functions in the form ax plus n being added or subtracted, you just take the derivative of it by one by one. I hope it's clear. So you take the derivative of this f of s plus or minus the derivative of this g of s, and you are done. You go your way. It is the same way, the power and the exponent, and you go your way. So maybe you are not seeing it well. Let's try some examples and you will get it well. So let's see y is equal to 2x to the power 6. So what will be, let's say you have to find the dy dx. So we have another function here and another function here. The question to ask yourself is it in the form as or n? Yes, because we can see the exponent, coefficient, and the what? The exponent. Coefficient and the exponent. So you can write this for our idea here. You can write this as so this means that we are taking the derivative of it or 10 by 10, even though the function was given to us as 1, but we can still do it 10 by 10. So taking the derivative here, you just multiply the power by the exponent, the coefficient. You get what? 12. Subtract 1 from the power, you get what? 5. Plus, you know the coefficient here is what? 1. So negative 9 times 1, you get what? Negative 9. Bring your x. Negative 9 is there. Then you subtract 1 from 8. So this, and with the derivative, but you have to leave it in the proper form. So we have already subtracted 1 from the 6 and we are having the 5 here. So here no problem. Minus, we have 9x raising to the power of negative 10. So that is that. So therefore, the dx of this function is that. And we are done. That is clear. Alright, let's try some examples and see how we can proceed for that. Okay. Let's see square root of x minus 2x, all this over square root of x. Wow. It's a nice question indeed. It looks like, say this one is too big. No, it's not too big. It's simple. Because you know that if you have a plus b all over c, it's the same as a over c plus b over what? C. So you having this and you want to leave it in the form a(n) to the power n so that you can see your power and your exponent. Just divide by each. So here you can get square root of x over square root of x minus 2x over x. You see how simple it is? Alright, so you can see that this will cancel this, so this will give you 1 minus this one will cancel this. And what do we have here? 2. Oh, beautiful. So that means that the question is just y is equal to negative 1. Oh my god. So this y being equal to this, sorry, there is a mistake somewhere. Thank you for that. There is a mistake here. This is square root of s. And that's why we are getting something like this. Now, I know you are a good student. Let's continue. So this will cancel this 1 minus here is going to be 2x over square root of x. We can still solve it by your idea in what? Indices and said or whatever. Just go your way. So let's see. This is the same as 1 minus 2x multiplying 1 over x to the power half. So 1 minus 2x being multiplying by x to the power negative half. So we can now get y is equal to 1 minus, we are reduced, this is not differentiation. We are just reduce the function that we have to be in a form that we like so that we can take the derivative of it. I hope you understand it. So we are just applying our algebra. So we have 1 minus 2. The s and the s be multiplied. So we get s, here is power 1. So 1 plus negative 2. So the function is the same as, calculate that. Oh, it is here, I'm not going to calculate that. You know the first half. Alright. So x to the power to the power half. So this is the function that we have. So we can now take our what? Derivative. So the dy dx is just going to be the derivative of 1 minus the derivative of 2h to the power half. So this is going to give us the derivative of this constant is 0 minus the derivative of this, the coefficient and the power. So this times this, we get 1 x. Then 1 over 2, subtract 1 from this. I hope you can see that. So the dy ds is just negative s to the power negative you can see that. Alright, when we were solving questions under the first principle, let's see, you see the long process we gone through before getting our answer. Let's see how we can use this technique to get the results. Simple. Yeah, simple. You just see it. I gave you a question like y is equal to 2x squared minus 3. Don't forget that we had 4x, right? We had 4x. And I gave you y is equal to 1 over square root of s, and that one to we had okay, divide this, go to this. That one too, we had this one is 4s, and this one too we had I think you less of it. After that you compare to that one and you see what I'm talking about. It's the same thing, we are going to get the same answer, but if the question says use first principle, you just have to use your first principle, okay? Alright, I know you are used to it, so you will do that. So let's see. So the divide yes will be equal to the derivative of 2s squared minus, close it here, the derivative of 3. So when you are taking the derivative of this, we have the coefficient and we have the power. So this will give you 4s minus the constant will give you 0. So the result is 4s. Oh wow! Yes, 3 steps and we have the solution. But the other one, oh, but still use it if the question is it depends on the question. Okay, all right. Let's see the other one too. Y is equal to 1 over square root of s. I forgot the answer we had for this, but you let's see. After that, you have a student compare. You can change this to y over this, right? And this is the same as this. Then the dy dx is going to be, the coefficient is 1, so negative. So we have negative half minus 1, and that will give you, so negative half. I want to point you so that you don't tell me that, say what we had from the first solution is wrong. So that formula, that idea is wrong. I like this idea. No, it's not wrong. It's still the same answer we are going to get. Alright. So when you punch your calculator, you get negative half of x raised to the power negative 3 over 2. It's the same thing, no? Watch. We can leave this as negative half. Then don't forget that we can bring this s down. Easy. So we can bring this s down so that we bring the 3 over 2 here. So it's still the same thing. And if you have, let me create more space here. If you have negative half s over 3 negative, let me write it so big so that you can see what. If you have this is the same as negative half square root of s to the power 3 from your indices. So the answer we had for that one is the same thing as you using this approach. But you see, this approach is just simple and just few steps and you are there. But it depends on the question, as I said. If you are restricted to use the first principle, use the first principle. I know you are used to it and you will do that. Alright, so you can continue to try as much as more questions you can. I want to explore you in more questions, okay? So we are still on the techniques. You can also get something like y is equal to 5s getting something like this. Is it in the form ax to the power n? Yes, this is in the form like that. We have the power, we have the coefficient. We have the power, we have the coefficient. So we can just conclude that this one, the ybs is going to be negative 5h to the power, because you subtract 1 from this, so you get negative 2 minus 1 is here multiplying this, you get the same thing, then you subtract 1 from this. Bear in mind, 1 is there already, so it will be 1 minus 1, which is what? 0. You see that? Alright. So, here you get negative 5s, negative 2 minus, since here 1 is there already, so subtract 1 from it, you get 0. And any number raised to the power 0 is what? 1. So here you get 1 over 5. There you are there. Trust me. Alright, let's try it. You can also get a question like y is equal to s squared x to the power 3 minus 5. Then you have to find the dy dx of this question. You can expand and simplify it, okay? So this time this, you get what? X to the power 5 minus this time this, you get what? 5x squared. Wow! So you see, it's now in that form. You see that form? Ax to the power what? N. Please. If it's not in that form, you can't use the idea. Don't forget it. So 5x to the power 4 minus 10x. And you are there. That is that. Alright. You can get something like this. One plus s squared plus s to the power 3 plus s to the power 4 plus 5. All this over x. Woo, sir. We haven't solved similar question like this, so I can't do it. Please, you can do it. We have solved similar, but then the numerator wasn't too lengthy like this. But the idea is just simple. Divide 8 10 by 10 by the denominator here. So we can get 1 over x. So this is algebra first before you take the derivative. So we can get this, 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 and we can get this. So 1 over x, you know 1 over x, 2 will be the same as s negative 1, plus this will be 1, plus this will be s, plus this will be s squared, plus this will be s to the power 3, and this will be what? 5s to the power negative 1. Don't forget it. Alright. So you now take the derivative 10 by 10, right? So you take the derivative of this, you have the coefficient there to be 1, you have the power to be negative 1, so you get negative 1 x to the power negative 2. And any constant is, any constant is 0, so that place is 0. Plus, here the power is 1, the coefficient is 1. So try 1 from the power, you get what? 0. Right? So 1 minus 1, you get 0. And any number which equals 0 is what? 1. So here you get 1. And here plus coefficient is 1, so 2x, because you subtract 1 from the power, plus 3 s squared minus, because the power is -1, so to go and multiply the 5, so you get -5 x to the power -2, and you are done for that. Just simple, it's not difficult. I hope you love mathematics. I also love mathematics. Good. Alright, so let's see the last technique, then we proceed to go through the rules of what? Derivative. So let's see another technique called the higher order derivative. The higher order derivative. So we'll be looking at that in our next video. Until that, love you. I hope there is no question. If there is question, you have my contact. That is 055 78 59 597 Prof. Leo. WhatsApp me with your question and I will attend to you. Go through the PDFs given you. It's a lot of questions there. Be solving it and it will help you. Thank you.